we're given an unsorted array nums with n elements, and each element is in the range 1 to n inclusive. Now, the array originally contained all elements from 1 to n, but due to a data error, one of the numbers is duplicated, which causes another number to be missing. Find and return the corrupt pair that is missing and duplicated. And now we have this example. So in this array, we have 1, 2, 3, 4, 5, 6. So it's supposed to go from 1 to 6. 1 is duplicated, so 1 is a duplicated number, and the missing number is 5. So return the missing number first and the duplicated number second. And we see the same thing here. We have 1, 2, 3, 4, 5. So it's supposed to go from 1 to 5. 2 appears twice, and it's the second thing we return, or the second element in the tuple, and 4 is missing, and so on and so forth. Okay, now let's look at the solution. So for the solution to this problem, just like the solution to the last two problems in this series, we're going to use cyclic sort, and the setup is the same, right? Very, very similar. The code setup, the code block that does most of the work is the same across all solutions. But the key to this is looping through, for instance, this array. And we have a cursor, for instance, here at 3. And 3 has a position within this array. So every time we see it in the wrong position, we swap it out with where it's supposed to be in place. And so the cursor is still here, and we keep the cursor here until we get the right value that's supposed to be here. So in this case, 2 is supposed to be here, so it's going to swap between these two, as you can see. And then the cursor is still pointing at 1, but now it checks, okay, is 1 in the right place? Yes. So the cursor moves here, checks if 2 is in the right place. Yep. 3 is in the right place. Yes, until we get to here. And so in this case, it's going to check where is 5 supposed to be. It figures out it's supposed to be here. Again, because everything goes from 1 to n. From 1 to, in this case, 5. 1, 2, 3, 4, 5. All the numbers are supposed to go from 1 to 5. And so 5 finds its rightful place. And then the cursor is still here, and we realize that 2 is in the wrong place. However, it's equal to what is at the right place, right, which is 2 here. So we know that, okay, this is going to be our duplicate, and the index here is index number 4, right, represents number 4. And so we know that the duplicate number is 2, and the missing number is 4. And that's how this works. Now, like I said, setup is very familiar if you've been following, right, the last 2 videos. This while loop does all the heavy lifting. Is our cursor moving through the length of the entire array. We store missing and duplicate that we're going to return at the end of the day. What the value is supposed to be, I mean, what the value is, right, at whatever the cursor is pointing at, -1. And again, we do -1 just to fix off by 1 errors because it's starting from 1 and not 0. And in this case, we're just checking, is it at the wrong index? Because if numbers in whatever is indexed at I, whatever I is pointing to, and whatever we have at that value, if they're not the same, then, and so if it's at the wrong index, we do the swap. Otherwise, we move the cursor 1 step forward. Again, similar pattern to everything we've seen so far. And then finally, we loop through everything from the beginning once again. This time we change the cursor to j. And if the value at j is not equal to j plus 1, we know that what's duplicated is what's at j, or what's missing is what's at j plus 1. Return that down here. C'est fini. And now we've successfully done this in O of n time complexity, and in O of 1 space complexity, again, because we use cyclic sort. Now feel free to step through this with a debugger, right? Just to see that, have proof for yourself that it actually works. Admittedly, some variable names maybe should have been different, but feel free to tell me in the comments what you think I should have named this value as I, maybe correct value at I. Either way, thank you for watching. Like, comment, subscribe, share. Thank you. See you next time.